SpaceX does many things differently, whether it's during the launch of a rocket or in the development of one. This innovative approach makes them the most successful in an industry filled with multi-billion-dollar companies. Perhaps one of their most unique strategies is how they handle the Starship. Although the ultimate goal for this rocket is to reuse it as often as an aircraft, they are currently using sea landings during orbital test flights. I know we haven't seen this in action yet because all the past 3 launch tests have ended in explosions, but the 4th flight is believed to be very different, and many experts believe that SpaceX will achieve this landing. And recently, Musk made a surprising statement about this topic, and we are going to talk about it in this video. Before we delve any deeper, please make sure to subscribe to our channel for future updates about Starship and SpaceX's other groundbreaking achievements. Like we already know, SpaceX has conducted 3 orbital test flights so far, 2 in 2023 and 1 in 2024. Now they are gearing up for the next one, and SpaceX seems quite ready. Musk even shared a video on Twitter of Starship fully stacked. If they get the launch license from the FAA, they might launch the rocket as early as the end of this month. However, there's something that's going to make this launch very different from the previous 3 launches. For the 4th launch, Musk says they aim to get through the high heating regime and then smash into the ocean at a controlled spot. SpaceX will launch the Super Heavy Starship into orbit and attempt to land on a virtual tower. This means Starship and Super Heavy will perform a controlled landing in the ocean, hovering over a specific point until it runs out of fuel and falls down. This method has many advantages for SpaceX. The clearest evidence is their practice of landing the Falcon 9 rocket on a drone ship. It took several attempts before they were confident enough to do it on a real drone. So how will Musk and SpaceX execute this landing in the 4th launch? Why don't they land Starship on a drone ship but instead let it splash down in the water? Landing rockets is one of the most challenging aspects of rocket launches, and it's even more difficult when dealing with larger rockets like the Starship. The Falcon 9, for example, stands at 70 meters tall with a diameter of 3.7 meters and a mass of about 549 tons. It generates around 7.6 million newtons of thrust with its 9 Merlin engines. Landing the Falcon 9 was no small feat and took several attempts before SpaceX could reliably land it on a drone ship. Each landing required precise control and timing to ensure the rocket touched down gently without toppling over or crashing. Falcon Heavy, which is an even more powerful rocket, combines 3 Falcon 9 boosters, making the landing process even more complex. The Falcon Heavy stands at 70 meters tall and has a diameter of 3.7 meters. But its first stage consists of 3 boosters, each needing to land safely either on drone ships or back at the launch site. The combined thrust of Falcon Heavy's 27 Merlin engines is 22.8 million newtons, and managing this immense power during landing was a significant engineering challenge. Each booster had to perform precise maneuvers to ensure a safe return. Now, consider the Starship. This rocket, including its Super Heavy booster, stands at 120 meters tall, has a diameter of 9 meters, and a mass of about 5,000 tons. It generates a staggering 72 million newtons of thrust with its 33 Raptor engines, which is a colossal increase compared to the Falcon family rockets. The sheer size and power of Starship make landing exponentially more difficult. The Super Heavy booster alone is as tall as the entire Falcon Heavy rocket. The payload capacity of Starship also highlights its massive capabilities. While the Falcon 9 can carry up to 22,800 kilograms to low Earth orbit, Starship can carry up to 150,000 kilograms to low Earth orbit, and more than 21,000 kilograms to geostationary transfer orbit. This far surpasses the capabilities of Falcon Heavy, which can carry up to 63,800 kilograms to low Earth orbit when fully expended. However, with this increased capability comes increased complexity in landing such a massive structure. SpaceX is not just going to drop the rocket into the ocean, they are going to perform many tests before landing the rocket. One of these tests is the belly flop maneuver, where the spacecraft flips over and re-enters the Earth's atmosphere with its belly facing down. This maneuver allows for a controlled descent and landing similar to a skydiver. To simulate this maneuver, SpaceX will drop the Starship into the sea. The orbital landing test flights did not start with straight up and down trajectories like the first prototype test flights. Even those trajectories were much more difficult than the engines flying sideways at full orbital speed. To be safe on re-entry, you need to re-enter the atmosphere somewhere on the other side of the ocean. If something goes wrong, it'll cause problems for the experimental spacecraft. SpaceX has carefully considered landing the Super Heavy booster in the Gulf of Mexico. The rocket's flight path over the ocean ensures all debris will fall into the water if something goes wrong. The final splash point is a safe distance in the Indian Ocean, although this location is not under U.S. jurisdiction. This method is the best way to ensure human safety and increase Starship's success rate. The belly flop maneuver involves the spacecraft using its large surface area to create significant atmospheric drag, slowing down its descent without using much fuel. The Starship has a sprawling surface area of 545 square meters on its windward side, which acts as a brake during descent, reducing its terminal velocity significantly. During the belly flop maneuver, Starship's engines draw propellant from header tanks to avoid propellant settling on the belly side of the rocket due to atmospheric deceleration. This ensures the engines have a steady supply of fuel, even as the rocket falls belly first through the sky. Another reason SpaceX avoids catching Starship mid-air with Mechazilla is to protect the ground infrastructure. Starship is still experimental and needs more tests before attempting a mid-air capture. Any additional hardware around the launch pad could suffer significant damage if things go wrong. Some people might see the ground infrastructure as just a concrete slab, but it's much more than that. The launch infrastructure includes complex and expensive components such as the launch tower, fueling systems, and control centers. These facilities are vital for the safe and efficient operation of the rocket launches. We can see the significance of this from the first flight test when Musk said, "Anything that doesn't damage the launch tower is considered a success." This statement underscores the importance of the ground infrastructure in SpaceX's operations. The cost of the ground infrastructure can be immense. For example, building a launch pad can cost anywhere from $50 million to $200 million. The risk of an unsuccessful mid-air capture could lead to catastrophic failures, potentially causing the rocket to veer off course and destroy the launch tower or other critical systems. Given the size and power of the Starship, any mishap could result in extensive damage. The Super Heavy booster, which is part of the Starship system, alone stands at 70 meters tall and generates 72 million newtons of thrust. And that's all for today's update. If you enjoyed watching and found it useful, please make sure to subscribe to our channel and hit the like button. Thanks for watching, and I'll see you in the next one.